Okay, so this is the second example and also the final example on rationalizing the denominator. And when we have what you see over here, which is a binomial, we have two terms here in our denominator, we need to multiply by the conjugate of that denominator. Okay, so the conjugate of 3 minus the square root of 5 . Okay, so this is the second and final example for rationalizing the denominator. And we learned in the previous example that if we have the square root of a in our denominator, to get rid of that, we just need to multiply by the square root of a on top and on the bottom of our fraction, or in the numerator and the denominator. In doing so, the denominator will have taken care of itself and become a, and the numerator becomes b multiplied by the square root of a. So that is pretty simple when it comes to a monomial surd in the denominator, right? But what about what we currently have over here, which is a binomial, 3 minus root 5? How do we go about something like that? And that is what we are going to look at today. So when you have a binomial, like we have here, we need to multiply by its conjugate, right? And the conjugate we can find in the following way, and I've mentioned it in previous examples. So if we have a binomial, in our case 3 minus root 5, the conjugate of this value is going to be the same values, right? 3 and root 5, but with the opposite sign. In our case, that would be positive. And that is what we multiply by. If your denominator was perhaps 2 minus the square root of 2, then the conjugate would be 2 plus the square root of 2, right? And those two values will get rid of the surd. So I've gone ahead and multiplied the original fraction by 1, okay? And what I chose to be in my blue fraction is the conjugate of this denominator that we want to get rid of, okay? So just pay attention to the red note over here. If you have a value, a plus b, multiplied by its conjugate, a minus b, the product will be a squared minus b squared, because these values here come from a difference of two squares, okay? And so we're going to apply that rule in our denominator now and say a squared minus b squared. So our a is 3 squared minus the square root of 5 squared, okay? And then in the numerator, you see that we're multiplying 4 with the 3 plus root 5, okay? So I'm going to write it out. 4 multiplied by 3 plus the square root of 5. All of that is over our line. And then it's just a matter of us solving this. So 4 times 3 is 12. 4 times positive root 5 is positive 4 root 5. And in our denominator, we have 9 minus 5. Remember, the square root of a value squared gets rid of the surd. So now we have 9 minus 5, which makes our final answer 12 plus 4 root 5 all over 4, okay? Now, before we finish up with this answer over here, you might notice that we can factorize this numerator. Yes, our denominator is rational, but if we factorize the numerator, we would actually get rid of the denominator completely. So we could say 4, which is 3 plus root 5 over 4, will give us 3 plus the square root of 5 all over 1 if you want to have it as a fraction. And there we go. Our denominator is rational, and we simplified the sum entirely. If you want to, you can go ahead and type this sum on your calculator, and it should pop out exactly the answer of 3 plus the square root of 5. Thank you for watching.